are complementary angles. Complementary angles, if two angles are on a straight line, they are supplementary angles, which means 180 degrees. Okay, so if you add the two angles, it's 180, and you solve for K. So and so on. By the way, this is actually in the test already. I know what is in the test. And I gave you two sample tests. If you do those two sample tests very well, guess what? You will do well in your own test on Wednesday. And also watch the videos, do the PowerPoints. It's not as hard as you think. Okay, so 1 minute. This is 1 minute written in. It's a 1 and a prime. You can call it 1 prime, but it's 1 minute. And you know there are 60 minutes in 1 degree. You want to remember this because you do some conversions. So 1 minute is equal to 60 degrees. 1 second is equal to 60 minutes. Therefore, there are 3,600 seconds in 1 minute, in 1 degree. 3,600 seconds in 1 degree, which means 60 times 60. Okay, and then you will go to some conversions, which you will be able to do. You should do some additions. This is PowerPoint 1. You already have it. I hope you know that all the PowerPoints you need are in folder 1. Okay, so but I think the best thing to do is let's start with practice. I believe if we start with some practice, then we will actually know what to do. We're not going to be reading it like we are memorizing it. So let's start with practice. Okay, now from what we just had, find the complement and supplement of the angle. This is homework 9.1. Homework 9.1. So these are the questions you will see in homework, some of them already in the test. Find the supplement. In other words, 29 degrees plus an angle you don't know is equal to 90 degrees. The supplement of an angle is another angle that adds up to it and get 90 degrees. And then you solve for x. Minus 29 on both sides. And your answer will be the missing angle. You write it here. What if I'm told to find the supplement? The supplement of 29 degrees is an angle 29. Let's call it angle y equal to 180 degrees. Therefore, y is supplementary to 29 degrees. Subtract 29 on both sides. And so now you put it in your calculator and get the supplementary angle. So that angle will be equal to 151. So use your calculator. The same thing. Find the complement. Find the complement of the angle. You can answer question number 2. If two angles are complementary, we already said they're equal to 90 degrees. 34 plus the angle equal to 90. Solve for x. Find the complement and supplement. The same thing. So numbers 1, 2. So where are we? We are in homework 9.1. So find the complementary angle. First of all, let me bring my unit circle first of all. And by the way, before I bring my unit circle, I want us to remember that 2 pi r, the circumference of a circle, is equal to 180 degrees. I mean 360 degrees. Sorry, 360 degrees. So that's the circumference. If I divide both sides by 2 pi, I will have r is equal to 180 over pi. So let's call this one radian. So 1 pi radian is 180 over pi. So anytime I'm told to convert from degree to radian, or I mean radian to degree, I will multiply by 180 over pi. If I am told to multiply or convert from degree to radian, if you know one, then you know the other one. So suppose I'm told to convert from degree to radian. I already know that 360 degrees, I'm going to start from 360 here. 360 is 2 pi radian. So if I divide both sides by 360, I get 1 degree is equal to pi. You know, this is pi radian here. So I will just have pi to go into 360 is 1. So I have a pi over 180. So 1 degree is equal to pi over 180 radian. I can put a small r there to show it's radian. What I'm trying to say is that if you can remember this, whenever you suppose I'm told to convert 30 degrees to radian, convert 30 degrees to radian, all I have to do is multiply 30 degrees. So I know that 1 degree is equal to pi over 180. Therefore, 30 degrees is equal to pi over 180 multiply 30. Then I simplify. This go into that, 3 go into 18. I have pi over 6. So 30 degrees is always equal to pi over 6. So I cannot forget this. Suppose I'm told to convert 45 degrees to so this is A, and I call this B. Suppose I'm told to convert 45 degrees to radian. So instead of wasting time, I'm just going to say 45 multiplied by pi over 180. And when I simplify, I know that I can just divide anywhere, but when I finish, I'm going to have, if I divide through here, I have pi over 4. Therefore, 45 degrees is always equal to pi over 4. All right, so let me do 60. The reason why I'm doing all this, we call them special angles. Remember when we were doing geometry, we call them special angles. So if we can remember them in pi radians, in radians, you are good. So converting 60 degrees to pi radian, multiply 60 by pi over 180. That, if you remember the multiplier, it's easy to do. So when I divide this, I see that 60 implies pi over 3. So pi over 3 radian. So let's go to 90. 90, so 90 degrees, if I'm told to convert 90 degrees to radian, 90 degrees is equal to pi over 180 divided by, multiplied by 90. If I cancel, I have pi over 2. So 90 degrees is always equal to pi over 180. So let me pull a unit circle. Before I pull a unit circle, but I'm going to pull a unit circle first of all. When I pull it up, because there are so many things involved in what we are doing, it's not just one thing. So let me go to the main screen and pull up a unit circle. Okay, blank unit circle is what I want to pull up. So now this is my blank unit circle. That's my blank unit circle. I can make it bigger if I want to, but let me place, we already calculated the special angles on the first quadrant. So this is 0 degrees. I hope you agree. I am looking at the standard angles. This is 30 degrees, and this is half of the first quadrant, 45 degrees, and this is 60 degrees, and this is 90 degrees. Let me write 90 here. So, you know what? All you actually need to know all these angles. If you know all these angles, you have a lot. You have not a lot, because I can now write their. Let's write their. Let's write the angles in terms of radian. So I can just put the radian somewhere and then write them in radian form. So let me write in blue. So 0 degree, and I'm going to call it 0 radian. But remember, we talked about 30 degrees, and we found out that 30 degrees is pi over 6 radian. We talked about 45 degrees. We know that 45, we found it to be pi over 4 radian. We found 60 to be equal to pi over 6 radian. We found 90 to be equal to pi over 2 radian. All right, so far we're not going to be too much in a hurry, but you see, if you know the unit circle in this class, no matter where we are, when we get to polar coordinate in unit 4, we shall still be talking about unit circle, directly or indirectly. Wherever we are, we shall be talking about unit circle, so you might as well know it. So this is the first quadrant. All right, before we continue, I just want to make us remember. We want to remember, I'm going to my whiteboard, and let us remember what we learned from geometry. Hopefully, you learn something like this in geometry. It's called SOHCAHTOA. SOHCAHTOA. And they all connect to right triangles. Forgive my crooked right triangle. And let's call this angle theta. And you see, this is opposite to theta, adjacent to theta, and hypotenuse. So let me just write opposite to theta. So I am... All right, so I am going to write that as the opposite to theta. So opposite, because I'm talking about theta. Adjacent to theta. Hypotenuse of theta. All right. Also, very soon we shall be, but what does so mean? So means sine. There are 6 trig ratios we need to know. Sine of angle theta is opposite to theta over hypotenuse. Opposite to theta over hypotenuse. All right. And cosine of theta. That's what we learned from, hopefully, we learned from geometry from high school. Cosine of theta is adjacent. All you need to remember it is SOHCAHTOA. It may not be in your textbook, but trust me, SOHCAHTOA has been running. That's what you need to remember. So this means that cosine is adjacent to theta over hypotenuse. So adjacent over hypotenuse, adjacent to theta over hypotenuse, and tangent of theta, tan theta, is opposite over hypotenuse. Opposite over hypotenuse. Okay. Also, the sine, cosine, and tangent, they have, I'm calling them And I call them brothers. They have brothers, or you can call them sisters. So sine theta has a sister or a brother that's called cosecant. If you did not do it in geometry, that's okay, because we are trying to summarize what you did. Very soon we shall start applying them in solving problems. But I want to just refresh your memory about your geometry in high school. All right, so sine has a brother called cosecant. I'm just going to write CSC, cosecant, CSC. And I will clean my big triangle here. I will clean it so that I can make it smaller. But even if I don't draw that triangle again, well, guess what? The cosecant is the reciprocal of sine. So since I already know sine, cosecant of theta is the reciprocal of sine, hypotenuse over opposite. Cosine also has a brother, call it a sister if you like, and that is secant. And secant of theta is the reciprocal of adjacent over hypotenuse. So now I can say hypotenuse over adjacent. Also, tangent has a brother called cotangent, and I'm going to just call it cot. Remember to read before you go and solve anything. Go to homework, anything. Read the text, read the PowerPoint 1. You go and solve homework 9.1. Then you read the PowerPoint 9.2. You go and solve. Don't dabble into solving, doing homework without. And then if you like videos, I showed you where to go and watch videos. You go and watch the author's videos. And then when I'm recording this class, so when I finish, you will go and watch what we did in class, whichever one you like. Feel free to watch whichever video you like. But I just want to let you know you have a lot. You have a whole lot to make you get an A in this class. But what you do not have is time. What you don't have is time. I can tell you that. So every minute you have, since you signed up for this class, every minute you have, use it to solve the problems. By the way, let me go back to, so cotangent is the reciprocal tangent. Therefore, it is hypotenuse over opposite. Not hypotenuse, by the way. Tangent is opposite over SOHCAHTOA, sorry. Opposite over adjacent. Opposite over, forgive me for that, opposite over adjacent. So let me go back and say it is adjacent over opposite. Cotangent is adjacent over opposite. Okay, tangent has no business with hypotenuse, so forgive me for that. Tangent has no business with hypotenuse. Okay, so cotangent is adjacent over opposite. Adjacent over opposite. So since tangent is opposite over adjacent, therefore cotangent, the reciprocal, is adjacent over opposite. Okay, and so when we call this the 6 trigonometric ratios. 6 trig ratios. Okay, all right, so I am going to go back. Hopefully you now remember this, and by the way, we have talked about this, so you know that's something called SOHCAHTOA. You use SOHCAHTOA to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. All right, so now I'm go back to that. Now I remember I was here